everybody that's totally watching us tonight.
Totally. That's probably everybody out there, because who wouldn't want to
Yeah, who wouldn't?
see us? Yeah, I don't know. And we're live
On
on both.
YouTube, did you see us on Twitch?
Dude, I see us now.
Woo woo. Dude, I'm watching us on Twitch, so, you know, take that.
Dude, I'm jealous.
Dude,
Dude, now I am too.
dude, it says
Well,
it's
it's
too
good.
quiet. Oh, there we go.
Who says it's too quiet?
Okay, we're good to go. No, I'm saying that's what it was saying. Well, welcome, one and all, to our live stream tonight, where we go over tutoring everything mathematical.
That's what we're doing.
Some might even say
Tuesdays we teach a math/physics lesson, showing how calculus is used in physics, and on Thursdays we answer questions. And if we don't have any questions, we talk about math and physics.
Yeah. Is Twitch live now too? Yes, it should be live now. It's showing up on mine. Yeah, so anyways, Jaden, we are professional Twitchers now, I think. Like that.
Okay.
Anyways, Jaden, you said that you had something that you would maybe want to go over.
Well, I was just looking at series, and a big thing with series is either the series will converge or diverge, and if it converges, that means the sum of the series is going to actually add up to some value. If it diverges, that means we don't have an actual value for it. Is that what your understanding is, Kip?
Yeah, that's an understanding that I have of that.
I didn't have any like specific series that we could go over.
Okay.
There's always geometric series or the harmonic series or those things that we can talk about, but those are just pretty standard.
Well,
Yeah.
if we wanted to, Jaden, something that we said we were going to maybe do a few weeks back but never got around to is we were talking about how when we were using kinematic equations, this isn't series, but if someone gets on, they can ask whatever question they want to ask.
Right.
But I guess we talked about this idea that the maximum of the maximum angle to shoot a projectile at is at 45 degrees. And so we could work through that tonight. It might be a little tedious, but it could be a fun, cool problem to go through.
Yeah. Let's dive into it.
Okay. So first thing we need, what just happened? The first thing that we need to remember is that we need to write we have our x and our y, right?
Right.
Components. So we're going to say that d, if my thing will let me right here, we'll say, Jaden, it's doing this weird thing again. Uh-oh. Look, watch.
So weird.
Watch what it does. Oh, now it's fixed. Okay.
I just had to be watching, didn't I?
Yeah. Okay, so we've got dy equals 1/2. Well, we have vi sine theta t, right, plus 1/2 at squared.
Okay.
Jen, do you want to write the dx out?
Sure. The x is going to look almost identical, but instead of sine, it's going to be cosine.
Okay.
Right?
Right.
That's what I would imagine it being. So vi cosine theta t plus 1/2 a t squared.
Cool. That's good.
Sweet. So your hypothesis, I guess, is that at 45 degrees, that is the furthest distance away from the starting point.
Yeah. Or so if we shoot it at 45 degrees, yeah, that's gonna one. So when we have a parabola, right, that goes boop, right, it's gonna be in the air for a certain amount of time, and that's gonna be based on a few different things. But the maximum travel, because Jaden, if you notice on this dx equation, we're actually gonna, because we don't have any sort of air resistance, this a is going to equal 0, right?
That is fantastic.
So we do get dx equals vi just cosine theta t. So now what we notice is that how far it's going to travel. So this is dy, and this is dx, right? Not to get, guys, this is displacement in the y direction, displacement in the x direction, not to get confused with derivatives, which is a little different. Yeah.
Yeah.
So this v, so if we just look at the dx equation, right, it's only going to be dependent on the initial velocity, the angle, and the time. We can show that the time is purely dependent on the dy portion, right? So
yeah.
Wait, it just stopped. No, what do you mean? It just got a comment saying it just stopped. I'm not sure what that means.
First comment was Kip's voice is slightly echoey.
Oh.
Oh wait, it just.
Okay. Hold on. I'm gonna check. Oh, I know why. There we go. That should have fixed that. Thank you for that.
Sweet.
Okay. So now we've got this thing that's going, or so we can find out the time based on how high it goes up, right? Because the only thing that's going to affect it is gravity. Anyways, so the idea is that at this 45-degree angle, it's going to be the maximum, it's going to be a mixture of sending this projectile forward and also getting the maximum height. So that mixture, right, because if we have an angle that's more flat this way, it's not going to be as, it's not going to be in the air as long, but it's going to be traveling much faster in the x direction. If we have an angle that's kind of going all right up, it's going to go up, but it's not going to go over as far. So it's trying to find that sweet spot between time in the air and distance traveled, right?
Okay.
Is that, yeah. So
yeah, that makes sense.
With that being said, what I think the best option to do is we can solve for time from the first equation for dy, and then plug that into the second equation, right? Because we're trying to find the maximum ds, right?
Maximum dx. Yeah. Yeah, that makes sense.
So in order to do that, what I think we can do is we can solve it as a quadratic, right? Shoot.
Hey, we have a raid on Twitch.
Awesome.
Dude, we've been raided. That's wonderful.
Dude, that is wonderful.
you come to the right spot to learn math and physics. Right now we are going over the optimal angle for the furthest distance in projectiles. Is that
That's what we're doing right
okay?
now. But if you guys have any questions, please just ask away. You can either send them to our email or you can send them. Awesome. That's what they were doing in physics last week, Jaden. So
That is awesome.
there you go. But yeah, if you guys have any questions, either comment in the chat or send them to our email, and we can definitely help you out with any questions
Yeah,
that you
like any
have.
homework problems that you want us to kind of tackle, or yeah, anything like that. That would be awesome.
Anything. Because
Okay,
we're super
let's
smart.
continue.
Okay. All right, Jaden. So we're going to solve for time for the first equation, right? So the first thing we're going to do is we're going to subtract dy and make it equal to 0. So we get 0 equals vi sine theta t plus 1/2 at squared minus dy. And then
Awesome.
from there, we can go ahead and do the quadratic formula on that, right?
Sounds good.
You want to do that part, dude?
Dude, only if you sing the song.
Dude, what song? Oh, that song. X equals negative b plus or minus square root a squared minus 4. Oh, wait, no, I messed up. Jane, I forgot the song. Uh-oh.
Yeah, you I don't even
X
know it,
equals
so I
negative
was
b
just hoping
plus or minus square root b squared minus 4ac all over 2a. Like that. That's how it goes.
yes, that was wonderful. um, so we have
Awesome that
in
you
this
know that song. That's a good song to know.
so in this situation, our b would be our initial velocity,
Times the
correct?
sine theta, though.
Times sine theta, yeah,
Yeah.
because our variable is c. So we have negative vi sine theta plus or minus square root of, it was b squared, so all of this squared. Awesome. Dude, you just wanted me to write all this fancy stuff out
Yeah.
because we're too lazy to write this out.
You know what? Jaden, maybe you're right.
For a, our a is 1/2, right?
Yeah.
That's a parenthesis, by the way. For a c, and our c is negative dy. And
Cool.
that is all over 2a.
Wait, we need an A in there for a C.
For a,
Or
oh, I need the,
you
yeah,
need the acceleration.
Yeah, sorry, my bad. Minus dy all over 2a, right? And our a in this situation, that represents the acceleration, not to be mixed with our fancy song. All right, yep,
Cool.
there we are.
Okay, well we can cross out this 2 and 1/2 down there. And we can cross out
Yes.
and that out, right?
So that becomes just a 2.
Yep.
And this becomes a positive
Yep.
because we have a negative in there.
Okay. Should we go to the next slide because we're out of room?
Yeah, I think so.
So now we get t equals negative vi sine theta plus or minus the square root of vi sine theta squared plus 2a dy, right? All
Right.
over a. Cool, cool. We're killing it so far.
Sweet.
Also, by the way, for all you guys that just tuned in, Thursday nights is when we do all of our homework help right now, and then on Tuesdays we do lessons. So tonight we're just messing with this stuff, but if you do have homework questions, please ask away. All right.
Yes. Did you
Did I
put
what?
the
Oh, no, I got to switch on here. Thanks.
yeah?
That's an issue. Cool. Thanks for that.
You think you could start the differential equation
Um,
x minus y dx plus x dy equals 0
ooh,
using substitution?
Jaden?
um, I mean, we probably
It's been a hot minute since I've done differential equations.
same. I mean, we could maybe look something up and try it.
We can go for it if you
Let
guys
me
want to watch us struggle. Because yeah, we should just try it.
let me look up. Yeah, we can try it. We can put this on hold.
Okay, so the first
Is
thing,
this
let's write it out. We got x minus y
just yeah?
dx plus dy equals 0 using substitution. Jin,
Yeah,
let's.
I don't ever remember doing substitution in um, differential equations. Um, but that doesn't mean that it's not possible.
Yeah, dude, it's been way too long.
Check this out, dude. Differential equations has a cool shark there,
Dude,
dudes.
what does sharks have to do with differential equations?
They probably like the predator prey modeling. I don't know. That's my guess.
Probably.
Um,
Should I keep going with this one, Jaden, while you do some research?
dude, sure.
Okay. Hang in there, Tracy, with AT. We are gonna have Jaden. We're gonna have Jaden go ahead and keep looking that up, and I will keep trying to solve this lovely thing we got going on here. Okay, so now from there we have this equation, which is dx equals negative vi, or no, not negative. We have vi cosine of theta. And we're going to go ahead and put a t there. And so we're going to plug this t into there. And so we get dx equals vi cosine theta, and then in parentheses minus vi sine theta plus or minus the square root of vi sine theta squared plus 2ADY, and this is all over A. Cool, cool. And then from there, we know that because this is a negative, there's no such thing as a negative time, so we're not going to take the subtraction here. We're just going to leave that as a plus. And then, Jane, how's it going, dude? You killing it on this differential equations?
Um, do we have an initial condition?
I don't know. One was not given.
That's my um.
But don't you have to
But yeah,
solve it?
I'm still looking at stuff.
Um, I don't know, Jin. Dude, I think the first thing I would do is like put the x's and the y's on the same side, right? Isn't that the first thing you do? No initial conditions, just using plus c. So
Just use C. Okay. Yeah, let's look at what we can do.
dude, you ready? Am I going to put this on hold? Because I'm about to take this nasty derivative, and I don't want to do that.
You don't want to do that nasty derivative?
No. For what I'm on.
Dude, I see that equation. I wouldn't want to take the derivative of that either.
So if you're ready to go, dude, then
so we want to get let's see, what was the question? X minus y
here, we'll go to a new page.
dx x equals 0. Okay, yeah, new page. So we want to make this into basically what it would be is like a derivative, right? So we want it to end up as dy over dx, right? Because that equals our y prime, okay? So we want to get that into this sort of form, okay? And we have a x minus y dy, and then it was plus x dx equals 0.
Yeah.
So we need to algebraically like manipulate this to get it to dy over dx equals something. Okay, I think that's the goal here.
I think that's the goal too. But that I don't know where we do substitution from there. Maybe when we integrate, we do.
Yeah. Let's get it to that form right
Hello,
now.
whoever just said hello to us, Woozil or whatever. Hi.
Related rates. Hi, it's Ian.
Yeah.
Is it Ian? Oh, yeah. Welcome back.
Yeah. Thanks for hopping on again.
So this is a differential equation. Someone asked us to solve this using substitution. I think the substitution part might come in where we have this extra y term.
Yeah.
I'm not sure for not for sure, you know.
Me either, dude.
We're just talking about it. Okay. So let's first. I'm just gonna subtract x dx on both sides. Let's see where that takes us.
Okay.
We have x minus y dy. Sorry, this is bad handwriting, but it's happening.
Okay.
Equals negative x dx.
Ooh, that's looking good.
That is looking pretty good.
Let's divide. Yeah, nice.
Minus y. Divide by x minus y. We hit dy equals negative x dx all over x minus y.
Do we want to divide by dx now?
Now we can divide by dx.
Nice.
Divide by dx. Woo! Okay, so we're in this problem right now. So we have dy dx equals negative x over x minus y. Okay, and now this is the part where
we can integrate it.
Totally sure. Yeah, now we need to integrate it with respect.
Oh, but we got that y still.
Yeah, that's the issue here.
Don't we want to solve for y actually?
We could We could try solving for y. You want to take that one? Let me.
I don't know, dude. It's been way too long. I mean,
Well,
technically, we claim that we don't do anything, above Calc 3 on here, but we're going for this. So,
okay. So this is a good thinker, that's for sure.
So Ian of Flag, I think you switch around the dx and dy.
Is that what he said?
That's what we've got. Yeah, we've got Tracy with a T says, I think you switched around the dx and the dy.
Switched around in the initial. Oh, we certainly did.
Uh-oh.
So that's gonna change what it looks like for sure. So this is a dx. This is a dy. Okay. Well, we can start off the same way, I guess, and then just divide by. Okay. Sorry, trying to fix all of these. Yeah, we switched around.
So the original question for all of you guys was in the chat. It said, do you think you could solve the differential equation x minus y in parentheses dx plus x dy equals 0? So that's the original. Okay, Jen.
Divide by negative x. Divide by negative x. We have x minus y dx now, right? Over negative x equals dy. And now we divide by dx. Divide by dx, sure, that looks good. Divide by dx. Okay, so now we're at x minus y. I didn't write that d, just pretend I didn't. And divided by negative x equals dy dx. Okay. Sweet. And now that is where we are stuck. Still.
I thought normally don't you like want your dy and your y on one or like on opposite sides or something? I don't know. It's been so long.
Yeah, is this more of an implicit differentiation? Let me.
Well, here, Jaden. I think don't you want it normally something like set up so you have like y prime on one side equals y or something? Or am I crazy to think that? Or can't you put dy on one side and dx on the other side and put your y's and x's on the same side and then integrate? Isn't that an option too? I don't know, dude. It has been.
Yeah, let's try that. Let's try that. Sorry, everybody out there.
So let's see here. My math teacher has us substituting y equals ux or x equals vy.
This is like
So it's some sort of u sub. Yeah, dude, we might just have to say we don't know.
Yeah.
Unless you have faith in us.
I mean, if you guys were entertained with us just being like,
Yeah, you can, if this is boring you, let us know, but if not, I don't know. Or if someone else has another question, we can keep working on this one as well. Tracy with a T,
So,
if, another option is, since we do this every week, if you have these questions, you can send them to our email in advance, and that way we can look at them beforehand, so we're not just completely stumbling over it as we go.
winging it.
But
So that.
but I think Jaden's got this.
Dude,
Did
I don't
you
know
having
if
a brain blast over there?
Dude, I wish. Uh, this might be separable equations. Because we have the two variables still on one side.
It's all good. We like to get confused. This part of the purpose of our channel is to show people that even, we've both got degrees in math and physics and stuff, and we screw up all the time. And so it's to show, in part that we're all human and we all make mistakes, even though teachers act like they know everything. But they don't, Jaden, do they?
Dude, teachers don't know diddly, dudes. Right, Kip?
Right.
Just kidding, they actually do. But they are well prepared for their lesson and they are well prepared to answer the questions that they give homework for.
Yeah.
So it's you might be amazed when you go into like a professor's office and you're like, hey, I can't do this problem, and they're just like, it's just like that. But it's because they already know what they're talking about.
Because they already did
They've
it like
already
10
practiced.
times.
Yeah, exactly.
But, uh-oh, we have a comment from someone who is a teacher and says,
Oh, we got an email.
cool.
Questions. Ooh,
Number
they're series
16
questions.
is what they're asking for.
Determine whether each series converges or diverges. If it converges, find its sum. Okay, we have a series, cosine squared k pi divided by k, as k goes from 1 to infinity.
Okay, hold on. I'll write that down here.
What test?
What is it, Jaden? Read it to me, dude.
Okay, we have the summation as k goes from 1 to infinity of cosine
Hold on, dude. You're going.
squared. Oh, sorry.
Okay,
I'm going too fast.
Okay, of what? Cosine?
Cosine,
Uh-huh.
and then you have the little
Yeah.
square. Whoop. Okay, yeah, sorry, you just did that. Of k pi,
K pi.
and all of that is divided by k.
Okay. And so we want to figure out if this series converges or diverges.
Right.
I can see direct comparison test by using, or being used by comparing to 1 over k. Would I think that would work?
What? I was wondering if you could help out with it. I can see the difference. Yeah, I say try that.
Should we try it?
Yeah, do you want to try it? I think I'm actually getting somewhere on our
Or in our
previous question.
Dude, you're gonna
So,
leave this to me? I don't know if I'm worthy of this one, but we'll give it a try.
you are way worthy. You are like the most worthy.
Because plugging any values into will probably be less than or equal to 1. Yes, that is absolutely right. So you can say that 1 over k is always going to be Greater,
Truly.
let's see here, it's going to be less than,
Less than
no,
or equal
greater
to
than,
the
yeah, greater than or equal to
yeah.
cosine squared k pi over k, right? And if a series that is greater
I'm
converges,
gonna grab a notebook. I'll be right back.
then it converges as well. Bye, Jaden. Just leave me here all alone. Yeah, so I believe it's been a while since I've done these rules. Direct divergence test. Yeah, so it's been a second since I've done these rules. Can you remind me if it's when you're comparing, is it that if it's greater than, like I've said, if it converges, then the series also converges. Is that correct? Jane, is that
Yes.
correct?
Did you say if k over or 1 over k diverges and it's greater than or equal to, then the other one converges
Yes.
or diverges?
And vice
Yes,
versa,
that
right?
is true. Yes, I believe so. Well, not vice versa, as in if that
If
converges.
yes, then it also converges, right?
Not necessarily in that situation.
You don't think?
The first is true. The other, I can't think off the top of my head if it's true, but I wouldn't just
For
say
direct
that.
divergence tests, the thing you have is 0, AK, BK, and if BK converges, then AK converges. Okay, so if BK converges, yeah. So in this case, BK is greater than, and if AK diverges, then BK diverges. Okay, so we're looking at first section, and Jaden, does 1 over K converge or diverge?
Isn't that just the?
It's,
Is it the harmonic series? I want to say. I don't know for sure.
but I feel like it converges.
A 1 over k.
Yeah.
Ooh. I think I was like just looking at this actually, but I can't.
Yes, 1 over K is the harmonic series, and when doing the integral test, which
Is the
shows that 1 over K diverges. Okay.
Yeah. So that means the other one would also.
Okay, so we've got 0 is going to be, and that's going to be less than, like that, and our AK in this case is going to be cosine squared K pi over K, and then that's going to be 1 over K. Alrighty. So, and if AK diverges, then BK diverges.
Yeah.
But is the inverse of that true then? If BK diverges, then AK diverges? I don't know, dude. Series, man. Gotta love them series.
This series.
Um,
So 0 is less than AK. So the way that is written, right? AK, that's being multiplied, where in our series we have it being divided. So I think it will also be true.
okay. So this diverges, right? Sure. Nailed it.
I think so.
Should I check on the Wolfram Alpha?
Does Wolfram do that?
Dude, it absolutely does that. And not only does it do that, it tells you which test you should do it by.
Then why didn't you lead with that?
Because I want to think I'm smart.
Dude, you are smart.
Dude, thanks. Dude,
Okay, how do I
Wolfram
get
does
rid of this?
everything. For all you guys out there that don't know that, Wolfram Alpha is your best friend when it comes to math, and I'm not getting to say that. So you should always use Wolfram Alpha. Also, along with that, they, what was I going to say?
Given that
Even if you don't
the
pay, is Wolfram free or do you have to pay a fee? So Wolfram Alpha, there is a paid version, but the part that I like about the free version is that you can type in essentially anything you want in their search bar. It will, you can type in this exact equation and then say, does it, diverge, I think. Or say, I guess maybe what you say is you say series of, and then type it in, and it will tell you whether or not it diverges or converges, and then there'll be like a show us steps button, and when you don't have the paid version, it will only give you like the first 1 or 2 steps, but that at least gets you in the right, I don't know, how to start it, and it gives you the answer as well. And so you know how to start, and you also know how it's going to end. And so when you're trying to figure things out, that can be very, very helpful, because I feel like most of the time when reading a math problem, the hardest part is just trying to figure out where to start. Wouldn't you agree with me on that, Jaden?
I agree.
So,
Yeah, that one diverges.
did you Google it?
Just like you
Did you say?
direct. No,
Oh.
I'm just the direct divergence test following the 1 over k is greater than that, and that diverges. But I mean, you can double check Wolfram if you're doing it.
Dude, I'm typing it in, but I'm.
Watch it say it converges, and then I'll just be like, "See ya, guys."
Yeah.
It was a pleasure.
Let's see here. All right, series of that. Dude, it converges when k does not equal 0.
Serious?
Let me see here.
K does not equal 0. Well, that it can't equal
Right.
0 because it's in the denominator.
Hold on. Sum of. No, wait, now it's saying it diverges. Okay. Yeah.
Yeah.
Why is it not showing me the first steps, though? Probably because I'm on my tablet looking at this and not on my computer. But yeah, the answer at the back of the book says it diverges. So yeah, we did this right. As long as you write this out, and then you can say that it diverges, right? So you can prove that 1 over k is always going to be greater than or equal to cos k pi over k, and then by the divergence test, you can say that because 1 over k is harmonic, that it diverges, and so therefore cosine squared k pi over k also diverges. Would you agree with that, Jaden?
Yes. I would.
Awesome. Okay, well, any more questions out there? And let us know if that answered your question enough. Check your email. Could we do all the parts? Okay. Jaden, we got more in the email.
All of the from that
Yeah.
that section 16 through 19, is that what you're asking for?
I would assume so.
Awesome.
Okay. For question 72, did we get another email?
No, we did not. Oh, yes, we did.
Yes, you got another email. Cool. Thank you.
And it's question about 72. All the parts. Okay. Ooh, Taylor polynomials.
Jaden, we were just talking about this the other day, weren't we?
Dude, yeah, I had a professor say, hey, take the 1 billionth, not actually Billy, it was like the 9th Taylor polynomial of this crazy trigonometric function, and everyone wanted to kill themselves while we were doing it. But then it felt good that we did it. But for what reason, I still don't know.
Because math is cool. It's math magical.
It was, yeah, it was really cool that we did it.
Oh, that last one was solved, Jaden. I didn't put the solved thing.
Yeah, good job. I was getting somewhere with this, and now I lost where I was.
Dang it. Sorry, I confused you.
No, you're good. I think I have it. Yeah, that is y over x. Is that -1? Yes. Okay.
Oh gosh. Okay, so we're doing 72, right? Use approximate y. So we're approximating y equals cosine of x at pi over 2. And so we want to graph cosine of x and y p8x. Use y p8x to approximate cosine of 88 degrees. What is the error in the approximation? If an approximation is a is used, what is the value? Oh boy.
Okay.
Okay. So Jaden, do you remember Taylor
Okay,
series?
let me look at that so I can. Okay, approximate.
I'm assuming
y.
you don't need the help with graphing y equals cosine x, right? I'm assuming you've got that part figured out.
Which one?
I'm asking them if they're aware, or because the first part said to graph this, and anyways. Okay, so Taylor series, Jaden, it's like 1 over some, it's like the derivative, right? And da-da-da-da-da. Yes, just the Taylor series stuff is bothering me, especially Lagrange error bound. Good.
So you're doing, use the approximate y minus using the Taylor polynomial of y equals at pi over 2.
Yeah.
Okay, so let me get to that section. 753.
Oops. I accidentally hit solved. That's what happens when you type an S. Okay. Here we go. Okay, so f of a plus f prime of a over 1 factorial x minus a, da 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 da.
Yeah, double.
So f of a is going to be cosine of pi over 2, right? So we get y equals cosine of pi over 2.
Yep.
And then, so then we want to take the first derivative, right, Jaden?
The Taylor series, you first have the function at the value a plus the first derivative over 1 factorial times x plus, that would be the Taylor series, right?
Right. So
yeah, we need to take, was that to the
Taylor
eighth?
series of it is -1 x squared k divided by 2n pi. Or what? 2n
Okay.
explanation. I'm confused by that.
What are you confused on? The Taylor series of
Yeah.
it? Oh, okay. Like actually found a value for it?
Right. Is
Is
the
that
factorial?
what?
I meant 2n. Okay.
Okay. Um, is a factorial, I meant. So what part exactly are you struggling on?
Yeah, that's kind of what I'm confused with too.
Stuck on part A, B, C, D,
E,
E,
F, G,
all
H,
of the above.
I. Jen, you know your
What is the
alphabet?
error? Do I know my alphabet?
So more parts D and E.
Okay.
What is the error using this approach? Yeah, Jaden and I get lost on the errors too. Do you remember how to do the error?
Um, I am. I remember doing the error approximations off the top of my head. I do not know.
Why not, Jaden? Don't you remember everything you were ever taught?
Dude, if only. Right. Let's see. So
Error is
D
also
says
known
what?
as remainder. Okay,
Right.
that maybe is helpful. Jaden, you got that in your fancy textbook there, dude. I know you
Dude, that's what I'm looking at.
do. I always get confused by the notation of how it's written, I think is where I get confused. Yes, it does ring a bell. It's just a matter of remembering how to do this.
Yeah.
You divide, I always got confused because I thought you had to like know what the actual number is and then you divide by the actual number or something. I don't know.
So let me look at that. You were saying that it is.
All right, anytime you make an approximation, it is desirable for this would difference between, so you have the difference r of x, so you have the function and the approximation. See, I don't understand this part. So
Um,
it's going to be small. Just write
here's
that,
one.
small.
n. Okay, so you're saying the series for the cosine is, let me write it out so we can kind of see it, because we're still going to need to use this to get the error.
Right.
Because you go to the certain point in your series and then you stop, right? And you add all those together, you get the value of it, and then then it looks like you're going to use, right, that is the series.
Yeah. So we got -1 times x to 2k, like that.
I believe it is -1 to the n, and then we have x to the 2n over 2n factorial.
Jane, where'd you magically
And
get
this
that
is
from, dude?
summation from n equals 0 to infinity. And then we get
But
this,
we only want it for the first 8 terms, right?
1 minus, yeah. So we just want it for the first 8 terms. That'd be 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus, because we're alternating between plus and minus, x to the 6th over 6 factorial plus, I got an itch on my hand, plus x to the 7 over 7 factorial.
It's not going to be 7, it's going to be 8.
What's going to be 8?
Because it's x to the 2n.
Oh, yeah, I messed up. We have 8 right
And
there.
dot, right?
8 factorial. And is that the 8th?
No, that's only the 4th.
Well, that would be, we're looking at n though, right?
Wait, what about the pi divided by 2? Isn't that centered at pi divided by... What?
Don't show up. All of the odd numbers don't show up. Right? Isn't that what we're getting here?
Yeah, I don't know.
Oh, wait, no, that doesn't make sense.
We also have...
Okay.
I don't know, dude, my
But
brain's
anyways,
fried.
Yeah. Wait, what about the pi half? Isn't the centered at?
Yes, it is. So doesn't that mean...
Yeah. So then we would plug in the pi half for x, wouldn't we? And that is when we have to use a fancy-dancy calculator to actually get the value of it. And once we do that...
What do you do, Jaden?
Yeah, I wish I could just say, once we do that, we do this, but I didn't do that, so we're doing this now. Right?
We have some comment
the...
or multiply to be more exact. Jaden, maybe we're confusing this person more than helping right now, to be honest.
Question, that series that I wrote down, is that what you are...
You have not frustrated us. This is what we love to do. We love to solve things.
Yeah. Is that the series, though, that you were talking about when you typed it in the chat? We'll get an answer soon, I'm sure.
Yeah. But thank you for apologizing, but there's no need. Yes, that is the Taylor series of cosine of x centered at 0. Okay, so you need x plus
Uh,
c.
So we are centered at pi halves. That's the problem here, right? Okay.
Then all I'm going to say is I think I almost failed Calc 2 because of this portion of calculus. But don't tell anyone out there that.
Okay, I won't.
Anyways. One day I'll figure out the beauty of series, but for now, I mean, I know they're really cool because that's how computers work, but
Okay, so the only difference that we have the minus pi halves in there now.
so it's x minus pi halves squared, right?
Yeah, let me just double check. And now that's so weird. How did that happen? So now okay, let me just write it down because that's gonna be a lot better than me just saying stuff. So I'm on the new slide, Kip.
What the heck,
6.
Jaden? Aye, sir.
This is negative x minus pi halves. And then it's going to be plus, and it's plus 1 over, that'd be 3 factorial to the x minus pi halves cubed.
Where are you getting that?
Wolfram. Okay. And then minus 1 over 5 factorial. I think it's 5, right? That would be the next.
Wait, why are we going odds now?
For some reason, when you center it at
Pi over 2, it becomes odds instead of evens?
I'm not sure why right now. I said Taylor series of cosine of x at pi halves. And that is what we have right now. And so on, right? It will alternate signs and you'll just do the odds. Okay, so that's going to be your series. We have to answer.
Oh, we need to figure out what the error is, Jaden. Find it.
Yeah.
0.00032.
Is that what you got?
That's what I guessed. You don't like my guess? That's rude.
Dude, I think it's cool. So that was centered at 0. Those are called Maclaurin.
I just realized
series,
that the TI-84 has a sigma notation. My bad. No worries.
Yeah, our bad.
Yeah, our bad because we are technically challenged at doing this right now. Okay, so we'll need it again soon. Okay, so the coefficient f of x minus a is the average slope. Okay, yeah, we got that. Towards an error. Okay. Why can someone not just give me an example? Oh, here we go. Approximate. Yeah. Where is it? Oh, here we go, Jane. I got it. I got one.
You did?
I got an example.
Oh, heck.
So what the heck? Hold on. So the approximations of sine 46 are that, that, and that. And then the errors in the approximation are just going to be f prime of c. What is c? Each of these three cases, c must lie somewhere between 45 and 46 degrees. I'm so lost.
So approximate using the Taylor polynomial. So I don't know if we need.
I don't know, dude. I'm confused. I'm confused about this. What I'm getting here.
We could just use the Taylor polynomial.
Yeah.
Just the eighth term. Add those up. We don't need the series stuff.
No.
Okay.
We just need math.
Dude, we just need the math.
Dude, we just need to math it, Jaden. Just math it out, dude. Should we put in our rules no series questions?
Yeah.
Okay. Just kidding. We love series. They're our friends. Okay, so you just take the last term of this polynomial, Jaden, and figure out what that is. That makes sense. Hold on. I think I'm having a brain blast over here.
Oh.
Right? Because your last
Yeah.
your last term in the polynomial is going to be your error.
So that would be and to do the error you plug in.
It's just going to be the 8th term, right? Because as you
But we still have the x in there. It's x minus like the
so you
1
just
over.
you choose a number. You can choose any number. I think that's is like within 1 degree, right, of where it was. And then you say that the error is going to be less than that, I believe.
Okay. Huh. So evaluate that. Correct you within an error of this.
In our case, the 9th term will be our error. Oh, yeah, the 9th term. Given the error function is the nth plus 1 term of our polynomial. Yeah, so the reason being, right, as you add more and more of these together, and this is why this is all of a sudden making sense to me.
So, yeah.
Yeah.
The reason why we have an alternating series, right? It becomes positive, negative, positive, negative. So each time you're either over approximating or under approximating. And that is why the next term is your error, is because that will make it an over or under approximation.
Right. And then the more and more you get, right, the closer and closer that approximation gets.
Yes.
And so that's why that works out that way.
Yeah.
Dude, that's totally mathematical.
That is. Wow.
Wow. Mind blown.
It is mind blown.
Thanks for giving us this question to help us remember and have our minds blown again. I'm not sure if we answered your question fully, but it sounds like you kind of answered your own question yourself.
Yeah. If the approximation in A is used, for what values of x is the error less than? Okay.
Did we help you
Does
understand this enough, or do you need more help? Because normally we're a little bit over when we normally end tonight, but we want to keep helping you out if we are helping. I feel like you're more helping
yeah,
us,
so
but
yeah, like Kip said, and I think you also said it, your ninth term is going to be the answer to D, right? And then in E, you're using part A, and so you have this Taylor polynomial to the eighth one, right? And you're just choosing your own x values to plug in to this. Like, it's pretty much just a big addition problem. And you figure out your own x value to make the error less than that. If that makes sense.
I think it makes
So
sense.
it might be one, it might be, I don't know. I would probably try one first just because that would seem easiest, but I don't know.
Yeah.
You might try other.
Okay, so thank you all for tuning in tonight. We really appreciate it. Sorry it was a little rough tonight, but if you send us your homework in advance, we can definitely be more prepared. So, when you get your homework, if you want to send it just like you have been, then to our email, then we can actually get it really nicely prepared and be ready to go through it really quickly. And then from there, yeah, we normally do this, like we said, on Thursday nights. We are in the process of getting our Discord set up, right?
Yes.
Yes. And yeah, so Tuesday nights, we teach lessons. Thursday nights, homework help. And there we go.